All right, welcome back, everyone. Lesson 2 for the week is again about dividing polynomials, but this time we are going to be dividing a polynomial by a binomial. So in order to do that, we are going to use what's called long division. And if you ever learn long division, you'll recognize this when I set this first one up. So in this warm-up, we're just using numbers, and we're going to practice a little long division here. So if you want to do this on your own, you could pause the video right now and try it on your own, and then run the video to see if you did them right. So in this first one, we have 625 divided by 5. So with long division, we always put what we're dividing by out front. So the 5 is what we're dividing by. And then we're dividing 625. Okay, so the key with long division is, since we have one digit that we're dividing by, we look at the first number, the 6, and we say, well, how many times does 5 go into 6? Well, it goes into 6 one time. And then we do 1 times 5 is 5, and we write that underneath. And we do a little subtraction. 6 minus 5 is 1. And then we're going to bring down the 2. So now we have a 12 instead of a 1. Same question now. We're going to say, all right, 5 goes into 12 two times, and then 2 times 5 is 10, and 12 minus 10 is 2. I probably should put the minus signs there so you see what's going on. And then bring down that 5, and then we say, well, 5 goes into 25 5 times. 5 times 5 is 25. And if we end up with 0 down here, that's a good thing. That means that the number is divisible evenly by 5. So the answer in this case is 125. And the 0 means we have no remainder that we have to worry about. All right, let's look at the next one. So in this one, we have 367 divided by 3. So the 3 goes out front. Whoops, I don't want that one. I want this. And we put 367. The symbol that I wrote there was the square root symbol instead of the division symbol. So just that little tiny slash on the end of the line makes a big difference for our symbols. So now we do the same thing. 3 goes into 3 one time. So we do 1 times 3 is 3. We subtract, we get 0. And we bring down the 6. And then, so this one's kind of unique because we got that 0. And that's okay. The 0 is kind of just a placeholder at this point. We typically don't write the 0 if we have a number like 6, because the 0 is kind of meaningless. But anyway, we asked the same question. 3 goes into 6 two times. 2 times 3 is 6. So again, we're going to subtract, and we're going to end up with 0. And we bring down the 7. Now 3 goes into 7 two times again. So 2 times 3 is 6. We're going to subtract. We end up with 1. And there aren't any more numbers to bring down. And since 3 doesn't go into 1, we always write our remainder as a fraction with the remainder in the numerator and what we're dividing by in the denominator. So our answer is 122 1/3. Okay, so let's look at another one. 567 divided by 5. So we're going to do 5 out front. 567. 5 goes into 5 one time. So 5 times 5, or 1 times 5 is 5. So we subtract that. We get a 0 again. Bring down the 6. 5 goes into 6 one time. 1 times 5 is 5 again. So we subtract. This time we're going to get a 1. So we didn't get a 0 this time. That's probably a good thing. So then we bring down the 7. So we have 5 goes into 17 three times. So 5 times 3 is 15. And if we subtract that, we end up with a 2. No more numbers to bring down. 5 can't go into 2. So we write our answer as 113 2/5. All right, so this just serves as a little warm-up for what we're going to do with these polynomials. We're going to use the exact same process to divide these polynomials by a binomial, but it's going to be a bit different because we have variables involved. We don't just have numbers involved. So let's just jump right in and give the first one a try. So we're dividing x squared plus 7x plus 12 by x plus 3. So we're going to throw the x plus 3 out here because that's what we're dividing by. And then we have x squared plus 7x plus 12. And the one thing I want you to notice is the order of the exponents in what's being divided, the x squared plus 7x plus 12, they go in order. So we have x squared, and then 7x, technically there's a exponent of 1 on that x, and then the 12 doesn't have a variable with it. So we went 2, 1, and then no variable. If you were to find one where it went 3 and then 1 and then no variable, that would be kind of challenging. There's something different that we have to do with those in order to do this division using this method. But for what we're going to do, all of them are going to be in the right order. So you're not going to have to worry about that. So here's how this is going to work. We're going to kind of look at this the same way as we did the long division with just plain numbers. But we're only going to look at the first term in what we're dividing by. So we're going to look at the x, and we're going to say, well, how many times does x go into x squared? And this is where we have to apply exponent rules, right? So x is x to the 1, x squared is x squared, right? So that means we need to multiply by just a single x in order to turn the x into x squared. Okay, so then we're going to multiply x times x and get x squared. And then we're going to multiply the x times the 3 and get plus 3x. Okay, and this is where it gets a little bit tricky because what we have to do is we have to subtract this thing. So our goal is always to eliminate the first term, and the x squared is going to be eliminated because x squared minus x squared is 0, and we're not even going to write the 0 there. But then we have to remember, with the second one, it's a plus 3x, but we're subtracting it. So it's 7x minus 3x is 4x. And then similar to the long division with plain numbers, we bring down the plus 12. And now we're going to repeat the process. And we're going to look at the x, and we're going to say, how many times does x go into 4x? Or another way to think about it is, what do I have to do to x to make it 4x? Well, I have to multiply by 4, or positive 4, right? So I'm going to do a plus 4 here. And then I'm going to multiply the 4 times the x plus 3. So 4 times x is 4x. 4 times 3 is 12, so that's plus 12. And then remember, I'm going to be subtracting that. And in this case, we eliminate the first term, which is what we want to do. We want to get rid of the 4x, and when we subtract 4x, that's going to happen. But we also, when we subtract the 12, we're going to eliminate the 12. So that's actually a really good thing because that means we end up with 0. And if we end up with 0, we have no remainder to worry about. And the answer is just x plus 4. Okay, so when we divide x squared plus 7x plus 12 by x plus 3, the answer is x plus 4. Okay, let's look at another one. So in the second one, we introduce a couple of new things. One is we have a coefficient of a 6 on the x squared term in the numerator, and we have a coefficient of 3 on the x term in the denominator. So that's going to change things a little bit, but it doesn't make it that much more difficult. So we're dividing by 3x minus 1. So we have 6x squared plus 10x minus 5. I'm going to extend that a little bit. Okay, so same process. We're going to look at 3x. What do I have to do to turn 3x into 6x squared? Another way to think about it is if you have 6x squared over 3x, what happens? Well, the 6 and 3 become a 2. X squared over x becomes an x, so this is going to be 2x here. And if you're struggling with that, remember x times x is x squared. 2 times 3 is 6. So we got 6x squared. So that's what we want. So what we're going to do is we are going to multiply that 2x times the 3x minus 1. So we end up with 6x squared minus 2x. And this is where it gets really tricky, because we're going to eliminate that first term when we subtract, which is good. But with the second term, the 10x and the minus 2x, what we're doing is we are subtracting a negative, because we have the subtraction sign out here and we have a negative sign here. We're actually going to be adding the 2x. All right, so we're going to add 2x, so that becomes 12x. And we'll bring down the minus 5. And then we're going to repeat the process. So we take the 3x and we say, well, what's 12x divided by 3x? Or how many times, or what do we have to do to turn 3x into 12x? Well, we simply just have to multiply by a positive 4. So we then multiply the 4 times the 3x minus 1, we get 12x. And then 4 times negative 1 is negative 4. And again, we are faced with this tricky situation where we are subtracting a negative in the second term. And if we've done the math correctly, we're always going to eliminate that first term. So in this case, yes, we are, because 12x minus 12x is 0. But negative 5 minus negative 4, we're subtracting a negative. So what we're going to be doing is adding 4. So we have negative 5 plus 4. That ends up being negative 1. All right, and I have nothing else to bring down, and 3x minus 1 does not go into negative 1 at all. So what I have is a remainder, and we're going to deal with the remainder the exact same way we dealt with the remainder in the examples with just numbers. So our answer is going to be 2x plus 4. But then we have to deal with this negative 1. So we're going to say minus 1 over 3x minus 1. So our remainder is negative 1, right? And what we're going to do is just add that negative 1 onto our answer, but then make sure we divide it by what we're dividing by, in this case 3x minus 1. Okay, so we're going to have a fraction of some sort. All right, let's look at another one, and hopefully this will start to make more sense. So here we go. We're going to divide 4x squared plus 8x minus 7. We're dividing by 2x plus 1, so I'm going to write that here. And I have 4x squared plus 8x minus 7. Extend that a bit. All right, so again, same process, 2x and 4x squared. Now, if I want to turn 2x into 4x squared, I got to multiply just by 2x, which is kind of cool. I'm going to multiply the 2x plus 1 by 2x, so I have 4x squared plus 2x. Remember, we are subtracting. So I'm eliminating that first term, which is good. Now I'm subtracting a positive number, so that means I'm actually subtracting. So 8x minus 2x is 6x. I'm going to bring down the minus 7. And then 2x and 6x, I have to multiply by 3, so I'm going to do plus 3. So then I have 6x plus 3. And again, I'm subtracting that. So the 6x eliminates, but then I have negative 7 minus 3. Because it's positive, I'm subtracting, right? So it's negative 7 minus 3, so that's negative 10. And 2x doesn't go into negative 10, so I have a remainder. And so my answer is 2x plus 3. And then I'm going to add the minus 10. And I will divide that minus 10. Notice how I'm putting the minus sign out front, but then I'm actually just dividing the 10 by what I'm dividing by. That's simply just to create an expression using the minus sign. So the negative 10, it's a negative sign when it's on the 10, but it becomes a minus sign when it's in the expression. It's kind of a weird little mathematical thing, but it's something that a lot of people confuse those terms, minus sign and negative sign. So then I have 10 over 2x plus 1. All right, and again, just to highlight it, there's my remainder, and I'm dividing by the 2x plus 1. Okay, let's see what you can do. There you go, 13 through 23 odd, just the odd ones, on page 358 assignment that's out on Schoology.